I will do this. I will first describe a bit, again, the problem, and I will present you a scenario just for you to get a bit into the topic and just to justify what kind of problem I have. And then I will just try to be as generic as possible and say a couple of things or a couple of strategies I consider when dealing with nonlinear integer optimization. Okay, so I will be using like this graph to motivate the problem and to explain a bit the scenario I'm using. So of course there are many details to this, and I don't want to get stuck into details, so I want to be more or less brief. But somehow I need to explain this a bit. So this, what you're seeing now is like an example of an automatically generated scenario that I am using to formulate my problem. So the green circles you see are like the coverage areas of some base stations, given some reference power. So I'm assuming they are circles just to simplify a bit, but this doesn't really matter. And you see that each circle corresponds to a red center, which is the position of the base station. And then, so in this case, I have just followed this 3GPP dense urban model. So I have like an hexagonal grid of macro base stations, and then I have randomly positioned small cells. Okay. And then these other red dots that you can see, these are the UEs that are distributed, like a bit of them or some of them are distributed uniformly over the area, and the others are distributed in a cluster way. So cluster are around some base stations. Again, this is just following the recommendations. So again, this is automatically generated just to formulate the problem. Doesn't need to be totally realistic, but somehow is realistic too. Problem is further complicated because we have like this front haul network, which is connecting all base stations to the central unit, which is this one. So currently the central unit has just only one connection, which is a bit unrealistic, but this doesn't really matter at this point. And then the problem is the following. So I have this chain of functions that I can select to position in either of these or in each of these base stations, or I can centralize them in the distributed unit, which is like a data center. As always, there is this trade-off. If I centralize a lot of functions, I can, or I assume I can coordinate interference in a good way. So if everything is centralized, I know all the information, all the transmission information of all base stations, so I can try to cancel the interference they will be suffering, because you can see like there are areas of big overlaps, and in these cases, users will be suffering from interference. But if this, for example, these two base stations know what each other is transmitting, they can try to cancel this interference. Of course, I mean, this should be done in a proper way, and this is beyond what I want to investigate and, of course, what I want to explain now. But in general, I just assume that the more it is centralized, the better the interference cancellation, so the less interference users will see. But also the trade-off is that when things are centralized, they require a lot of capacity through the network. And this actually increases dramatically. So if I want to centralize everything, the capacity will be crazily high. So it will be like 600 gigabits per second per base station. So if I assume that I have an optical link of 1 terabit per second, basically I can just handle one base station with total centralization. Of course, it can be larger, it can be 10 terabytes, why not? But still, it doesn't scale very well. So then the idea is that given this network and given this situation, I have limited resources on what to centralize and how much to centralize. So I can centralize to some extent, so this I assume, but I cannot centralize everything because it's totally crazy if I want to do this. So the question is, what are the functions I should centralize? So what is the optimal functional split for every base station? And you can see that this shouldn't be like just, I can say that on average or given this network, I can afford this average centralization and I just centralize this much, all base stations. This wouldn't make sense because some base stations are like this, like they deal with a small number of UEs. Some other base stations deal with much denser areas. So of course, I should try to centralize those functions that I can get the most revenue of, which in this case means that I have to centralize those functions from which centralization, so for whose centralization I can gain the most, or the most interference cancellation. Mm-hmm. Okay, so this is basically the scenario. Do you have any question to this?
I had some question, but somehow it's clarified. I will just ask them to repeat and make sure. Mm-hmm. So the whole backhaul of the base stations are completely shared. I mean, shared with respect to the lines you have drawn on this map.
Yes. So I assume exactly it's not one like point-to-point connections. If this is the case, it will be, of course, very expensive, especially if you want to have many base stations. But if this is the case, you don't have any problem like this. So I'm with you with the problem, like if you have some kind of network connecting your base stations to your centralized unit, which is actually quite realistic, because point-to-point connection to every base station is not very realistic.
And then you said optimal, and then you mentioned revenue, and then you said this is interference cancellation.
Yes, revenue, I meant like interference cancellation. So not money in this case.
And how do you then measure interference cancellation?
Exactly. So this is now the program formulation.
Okay. One more question from my side. You said you have this 600 gigabits per second traffic if you want to centralize a base station. Where does this come from? So how often do you have to provide this information to the central entity?
Yes, actually, I mean, it depends on a lot of things like the number of antennas and so on. But in general, this high bit rate that you require comes from sending IQ samples for the RF signal you are receiving or transmitting.
So it's the entire IQ samples.
Exactly. So it's like the base station or the distributed unit doesn't know anything at all. It just receives and sends IQ samples.
Okay.
And this can be like large bandwidths, and it can be 64 antennas. So you have to send 64 times your whole bandwidth. And you want to do this, of course, I mean, it's a large bandwidth and you have to do it real time. So it requires a lot of bandwidth, a lot of bit rate to do this properly.
Are you considering also a higher level abstractions like the SNR of every antenna, the instantaneous SNR of every antenna or something like this, which would not require that much amount of traffic?
The SNR, what do you mean by SNR?
If you know the instantaneous SNR, it depends on how the problem looks like in the end. So, but maybe there is a way of reducing the amount of traffic to do interference coordination.
I mean, yes. So far, the ways I have considered to reduce this traffic is to change the functional split. So instead of centralizing everything, you may centralize some things, but not until the FFT, for example. And this serves you to reduce a bit the traffic. And if you don't centralize the physical layer, just up to the MAC layer, then you reduce the traffic further. So of course, maybe there can be like other tricks to reduce the traffic, but I haven't considered this.
Okay.
Or if you have another split, like this MAC feed split, then they're not IQ samples anymore. They're just like MAC PDUs that are transmitted. And still they are larger than the useful data rate that will see the user. So you have like some overhead, but this overhead grows a lot the more centralized you go. Like with full centralization, it's crazily high. Like for 4 gigabit per second useful data rate, or even less, but let's say 4 gigabit, you need 600 gigabits per second on the front haul. And if you don't have anything centralized, this will be 4 gigabits per second for useful data rate and front haul data rate. So this is like the trade-off. But of course, you cannot cancel interference, and the user maybe won't see this data rate because of you have interference cancellation. So there are some other trade-offs there. But again, this is maybe getting too much into detail.
Of course, exactly. Sorry, just curious. Thanks.